Hmm. All my friends are learning Rust, Scala, Python. Those hipsters. Telling me that Java is dead? I wonder if there's a lot of jobs in Java out there. Did you just see that? There's tons of work for Java right now. Officially, Java is the fourth most popular language in the world, coming after only Python, C, and C++. Even though it's in the fourth position, Java has almost the same amount of jobs as Python, which is number one. The amount of work for Scala and Rust compared to Java, it's not even a 1%. It's really small. So how do you get a piece of the pie when it comes to working with Java? In this video today, I will show you a roadmap of skills that you need to know to be a junior or a senior Java developer. So if you're starting with computer science, or if you're a junior developer and you want to know more about the skills that you can develop, watch this whole video because it's going to be really relevant for you. If you're already a mid or senior developer, you can skip a few chapters and get to the part that is best for you. Oh, and by the way, starting from today, every new subscriber to my channel will have a chance of winning Uncle Bob's Clean Code book. Isn't that awesome? It's literally one of the best books I ever read about programming. It talks about best practices of coding, clean code architecture, how to keep your code elegant, and it will make you a better developer. So subscribe today and don't miss a chance of winning that book. As soon as I hit 1,000 subscribers, I will send a hard copy of that book to your house. Alright guys, let's get right into it. We are gonna make a Java ninja out of you. So first we're gonna look at the basics to become a Java programmer. So before everything, you need to understand computer science fundamentals. I'm talking about the basics of computer science. So that means logic, which is how a computer basically thinks, and or XOR. This is the low-level logic of a computer. Also, you need to understand the basics of data structures, how computer systems are able to store information in the form of data structures. Also, having an understanding of networks is very important. TCP/IP protocols, things like that. You have 7 layers of different elements of a networking environment, and you should understand those. It's also very important to understand operational systems, obviously, because this is where all of the computer programs are going to be running in. So you need to understand how operational systems works, which are the components that compose those operational systems. And as a software engineer, you will be mainly focusing on Linux-based systems, so Unix-based systems. The most famous is, of course, Linux. And if you don't know, Mac OS is actually built on top of Unix. Last but not least, you need to understand algorithms. An algorithm is a way of solving a problem. You have many algorithms, and each one of them is designed to solve a certain computer science problem. So studying algorithms and understanding how they work and how to create them. Once you get that done, you're going to focus on Java, which is the main tool that you're going to be using to build the software. So when it comes to Java, here I added another black level Java, which is things that you should know as a senior developer, but for now we're going to focus on the junior side of it. So understanding inheritance, it's very important because this is one of the main object-oriented topics when it comes to Java programming. and it will give you an overview of how to structure your code by having a parent-child relationship in your classes, right? You will also have to understand how generic works, and this is quite an important topic because this allows you to have different kind of classes inside of a container. Let's say like for example, a list of items can be of different types, and to allow that structure in Java you have generics. Also, you will study, of course, the basics, which is conditional structures such as the if clause. You will also learn how to use collections, which is a JDK specific library that implements different data structures that we mentioned in the computer science fundamentals. Also, you will learn iteration structures such as for loops and while. You will have to obviously understand how variables work, so you are able to store values inside of those variables and use them to build your programs. Classes and interfaces are obviously the most important part here. You cannot have a Java program without a class. All of these things here, they tightly relate to object-oriented programming, which is in the end is Java. Streams are also a way of dealing with collections in a more of a functional way. So functional programming is a different programming paradigm that is being brought to Java now in the latest versions starting from Java 8. So what else? What else do we have here? Let's see. In order to be able to build Java applications, you need to understand how Maven works. Usually you need to understand how plugin works. Plugins are things that you can add to your code in order to change a behavior during the build phase. So when I talk about the build phase here, you are essentially constructing your application. It's very important also to understand how a multi-module project works and how it's structured. So usually when you have a program, it's composed of different modules. Configuration module, application module. You can have a testing module separate from your main module to do end-to-end testing and things like that. Maven is also responsible for managing the dependencies of your application, which are pretty much things that your application uses from the outside world. Also, it's nice to understand how profiles work in Maven, because they will allow you to execute Maven in different ways based on certain parameters. So for example, if I want to run my application in a test profile, I can do that. If I want to build the application to production, that's another profile. Now let's talk about the tools. I added here things like understanding the terminal. So the terminal is the command line, and it gives you access to a Unix or Linux system. And it's very important to know how to use the terminal, because you're going to be doing a lot of operations as a software developer. Also, it's important to know how to use an IDE, which stands for Integrated Development Environment. The most popular IDE for Java is IntelliJ, and this will allow you to develop your applications way faster. Instead of just opening a block of instead of just opening a notepad and typing your code in there, IntelliJ will have a lot of features like auto-completion and suggestions, Java docs, formatting, all the good stuff. I also added Postman here because it's important to you know how to use a tool that will allow you to test your REST APIs. Most of the work you do as a Java developer is creating applications that connect via REST, which is a standard of communicating by using HTTP. Let's check out the must-read books now. I added some books here. I added the Design Patterns book by Eric Gama and the Gang of Four. So this is a very famous book that talks about design patterns. And what is a design pattern? Design pattern is a very well-known way of solving a problem. So here in this book, they describe different patterns. Very experienced programmers realize that they repeat themselves, and the design patterns, they help you solve those problems. Also, a good idea is to read the Clean Code book, which I mentioned previously. It's an excellent book, and it will make you really a very good developer. That book is, for me, the best book I ever read about programming. Also added here a link to the OCP Java 17. This is a book about the certification program to become a Java developer. So if you read this book, you will learn Java for sure. So all of that stuff here obviously is mentioned in this book and much more. This book is a good source of content if you really want to learn Java. So as you see, these branches here, they go to further reading and monitoring and logging, and all those things are already part of the senior developer. So first I will talk about the junior developer and things that relate to him here. And then we're going to explore what makes a senior developer. So on this branch here, you have Spring. Spring is the main framework for web development using Java. In my 10 years of work, 8 of them was using Spring to create applications. So when it comes to Spring, what you need to know as a junior developer is obviously the basics. So understand how dependency injection works, be able to create REST services, be able to understand the services or the service layer inside of Spring, because Spring is a MVC framework. That means that it separates quite clearly the responsibilities of the code. And service layer is the main layer where you have your business logic. You also need to understand how to configure your application using the configuration classes, how to inject properties, and also Spring Data is a part of Spring that allows you to easily manipulate database. Usually every application that is written in Spring, it connects to a database at some point because you need to store the data somewhere. Spring Data is one of those things that allows you to do that effectively. So besides that, you have testing basics, because you need to know how to test your software to make sure that it's working properly. So what I added here is a few tools that you're going to be using. The main tool, of course, is JUnit. Right now we're at the JUnit 5 version, and JUnit is the base for writing unit tests for your code. Together with JUnit, I suggest using an assertion library such as AssertJ. AssertJ is a library that will allow you to fluently express your assertions. It's really easy to write assertions using that library, and it makes your tests way more expressive. Of course, you need to use a library to mock parts of your code. In that case, the most used library is called Mockito. And of course, you have a mock MVC, which is a library from Spring that allows you to write tests on a higher level. So not unit tests, but kind of like integration tests, where all the components of the system come together. So you can test layers of REST controllers, for example. You can test separately the database connectivity, and this is already from the Spring testing part. Besides that, a junior developer must know about databases and how to store data in them. So that's why I added this link here. And for databases, what is need to be known from a Java developer? Of course, it's the SQL syntax. So how to write structured query language, which is used in the most popular databases such as Oracle, Postgres, or MySQL. Understand how tables work, of course, the relations between those tables, and how to normalize those tables in order to have a more efficient design for your application. Remember here that databases, they don't change much, and it's better to design the tables well before you start working. Because once a table structure is defined, it becomes quite hard changing it, because you already have data in the table. Of course, I added here JPA, which is Java Persistence API, which is responsible again for making it easier to correlate and connect Java programs with databases. So JPA involves things like the criteria, query language. You have also the web drivers that allow you to connect to certain databases. So all those things are involved here. I realize it's a lot of stuff, but most of this stuff is required for any developer to have, not just a Java developer. Let's talk a little bit about version control now. Git is the main version control system, and version control is basically having different versions of your software. Software is code. It's written in text, right? And that code changes. So you have different versions of it. Git is nothing but a way of controlling that across multiple people, across multiple organizations in a very smart way. So I think a few things to understand here is how the repositories work. How do you create branches? How do you commit your changes? How you do stashing for times that you don't want to commit your changes and you just want to put them aside. And of course, GitHub is, let's say, the main social platform when it comes to coding, and it's good to have your projects hosted on GitHub, samples of your work, and many companies, they use GitHub as their main version control system. Docker was created as a container solution that allows you to store an application, for example, a Java program, inside a mini container. So what that means is that those containers, they're independent systems that they're running separately inside of the Docker machine. So this is important to be able to simulate how your application will run in a production environment, for example, because in both you will have your application inside of that container. So things like networks and Docker files to create these Docker containers, volumes that allow you to connect to external data sources, images. Again, a Docker image is, let's talk a little bit about Docker as well. Docker is important to be used because it can isolate your application inside of a mini container that has a little bit of an operational system, it has a little bit of a data storage, and it can host your application inside of it. And that unit, it's very easy to replicate across different environments. When you develop an application, you usually have test, acceptance, and production environments, which you drive your application through until you reach the maturity to put it in production. And Docker is one of those tools that allows you to do that. So you can see Docker as a mini virtual environment that has its own network capacities. It has its own volumes, so basically data storage sources. And once you package a Docker application, you use a Docker file. This is where you describe how the container will look like. And once that is published or built, it becomes an image. So that's why I added here the basics of Docker. It is quite important as a junior developer to use that, because probably the organization you're gonna start working for is using Docker. So with that said, I think I went over all of the basics here. If you draw a circle around this line, this is the stuff that a junior developer should know. It's a lot of stuff. So guys, as you can see, the Java market is booming. There is a lot of jobs for you out there. You just have to learn the skills. In today's video, you saw exactly what skills as a junior developer you need to have. I know it's a lot of things, but you can master all of that in 6 months. This is for sure. You can easily follow my Kaggle to create a plan for yourself. Just do a to-do list. I'm gonna leave a link in the description so you can open this Kaggle and maybe create a plan for yourself based on the contents of the presentation. I thought it was going to take me less time to explain you all of the things that a junior programmer must know, but unfortunately it took me 17 minutes. So what I'm gonna do is I'm gonna release a part 2 of this video where I talk specifically about the skills that a senior developer needs to have. So I'm gonna expand on that Kaggle, and we're gonna analyze everything that a senior developer must have in order to find a job. Of course, don't forget to subscribe to this channel to be able to win the Clean Code book that I'm gonna be handing over for you guys once I reach 1,000 subscribers. I hope that's not gonna take too long. As always, if you have any questions about the topics of this video or anything else regarding Java programming, freelancing, or anything like that, feel free to drop a comment and I will be glad to answer. Thanks for watching, have a great rest of your day, and I'll see you on the next video.